All right, welcome back. Today we're going to talk about ratios, rates, and conversions. So to begin with, we want to talk about what a ratio is. So a ratio compares two numbers through division. So we can take two numbers, let's say that they're A and B, and the three different ways that we can write them because they are in a ratio would be obviously A divided by B, A colon B, still said A to B, and then the verbal A to B. So a ratio that compares quantities measured in different units is called a what? Well, it's actually right here. Is called a rate. And a rate with a denominator of 1 is, of course, our unit rate. Like what it costs per ounce of cola or what it costs per gallon of gas. Although that would not be the total price, that would be your unit price. So now we will get on to comparing some unit rates. So Trisha ran 10 kilometers in 2.5 hours. You can see how fast Jason and Olga ran, and we want to talk about who ran it the fastest. So the one thing to do before you pause and try to take this on your own is speed is always going to be distance divided by time. Alright, so we set up all of our rates for Trisha, Jason, and Olga. Now Trisha's rate is pretty easy. When we do that division, we get 4 kilometers per hour. Remember, we have distance on top, time on bottom. The rest of these are going to have the same label, so I just won't label those. When we take Jason's time, his 7.5 divided by 2, we get just a tad bit slower. He was at 3.75. And Olga actually ended up running the fastest. When we do that division, we get 4.2 repeating, which means that she is our winner with the fastest speed on average. All right, we're going to do the same thing here with Bellingham, Washington, and Bakersfield, California. So pause this, set it up at least, if not even just solve it all the way through. All right, so when we set this up and solve the math, we put our people over top of our square miles, and we get approximately 2,900 for Bellingham, and for Bakersfield we only get about 2,600. So that means that Bellingham has a higher population density, or more people per square mile. So another thing that we will do using rates and conversions with rates is to convert different units. So we know that we have two basic systems of measurement. We have our American system, inches, feet, miles, all of that, and then we have the metric. And the metric system, if no one has ever told you before, makes a whole lot more sense. So this is exemplified down here with conversion problems like this. Take a moment, try to figure out what is 1,250 centimeters converted to meters. And one thing that'll help you is if you think about what is it that the prefix centa stands for, and if you can't remember, think about century or anything like that. Alright, so when we're converting, we like to set up ratios that are all multiplied with each other so that in the end you still just only get one unit. And we do this by taking what we have to start with and setting that in a ratio over 1, because we know anything divided by 1 is just itself. And then because we have centimeters on top, we can put centimeters on bottom and they will cancel with each other, and whatever is on top will now become the units that we get at the end. And we could multiply again and again and again, continually canceling out units, which is often what you have to do in the American system. But in the metric system, we know that centimeters in 1 meter, well, we know that there are 100, yes, that's right, centa means 100 centimeters in 1 meter. So when I divide 1,250 by 100, because of the two zeros, we bump my decimal over 2 places, and we now get that that is approximately 12.5 meters. All right, try number 3 and number 4 on your own. No cheating. Pause the video now. All right, since we start with yards and we want to end with feet, we set up our nice little ratios where we have 63 yards on top, 1 on bottom. Since I want to end in feet, I could go ahead and I know that feet will be on top. And is there a conversion of yards to feet? Yes, there is. Now, unlike our last one that we just did, we're going to have 1 on bottom here because 1 yard is equal to how many feet? That's right, 3 feet. And when we do this multiplication straight through, we get 63 times 3 gives me 189 feet. If you didn't try 4, try it now. And on number 4, when we set up with hours that were given over 1, and then I forgot to mention this that we keep using to multiply, the little like conversion that we know in our head or that we can look up, that I like to call our conversion factor. So we take what we start with, we multiply by a conversion factor, which will always compare 2 different units, and then we get our answer of 7 days, and the math works out perfect on that one. Alright, here's the important info highlighted in number 3. We start by knowing that a building is 1,450 feet tall. We want to know how many meters it is tall, and we are going to use the conversion factor of 1 meter equaling right about 3.28 feet. Pause the video and try to set this up now. Alright, if you are struggling to get started, this is what it should look like. You set up what you have over 1, you leave space to multiply by a conversion factor, and you write out what you know you want to end in, which is your meters. I always include my labels in my conversion factor because as soon as you don't use a label, you will set it up upside down and you will do the wrong thing. Take that from someone with experience. So I always advise you to use these labels. When we multiply through, we would get 1,450 over 3.28 or divided by, which gives me right about 442 and 7/100ths, running out of space, 7/100ths meters. Alright, go ahead, try to set up B and solve it on your own. Alright, here we are set up with what we know to start with. Over above 1, we know that we're looking for euros in the end, and our conversion factor will go right there in the empty fraction. And when we set it up and do the math, we get that you would get about 204 and 75/100ths euros on that day. Now, mind you, the exchange rate, as it says here, varies from day to day. That exchange rate is probably very outdated at this point because they change quite quickly. So, go ahead, and if you don't know the conversion from kilograms to pounds or from feet to centimeters, I encourage you, because you're on the internet, find a way. Don't use Google Converter, but find the conversion rate. Alright, if you do a Google search of kilograms or pounds per kilogram, you can see that 1 kilogram equals about 2.2 pounds. Normally we use 2.2 unless we need to be very accurate. So let's use 2.2 and come back over here. So we know there's 2.2 pounds per kilogram. So if we set up our 5 kilograms over 1 times, well, we know that kilograms has to go on bottom. What we found was 1 kilogram has 2.2 pounds. Pounds, the abbreviation is LBS, in case you were unaware. And 2.2 times 5 will give you 10.1. Actually, no, 11. Sorry. 11 pounds is what we should get with 5 kilograms. So now for 2 feet to centimeters, we want to do the same thing. Now I like searching for what I don't know first, so I say centimeter to feet, and it already pops up. And 1 centimeter is 0.03, yeah, not great. So if we switch it, we make this feet and that centimeter. This is much easier to work with. So let's use this as our conversion factor, that there's 30.48 centimeters in 1 foot. I can go over and try to set that problem up. So we can set up 2 feet over our 1. And go ahead and finish this out. I'm going to pause the video to save some time. When we plug in our conversion factor and set that up, we get 60.96 centimeters in 2 feet. So now try problem 4. Athlete ran 100 feet in 3.1 seconds. At what speed was the athlete running in miles per hour? This is always fun. We actually just did a lab about this, and we had one of my 8th grade basketball players riding on a little girl's bicycle and clocked his speed and then converted it to miles per hour. So go ahead and try this problem on your own. One conversion factor that you might need to know for this is that 5,280 feet make up 1 mile. Alright, here it is going to be important to have some accuracy. We want to convert our feet to miles, so obviously 100 feet is not going to be very much of a mile. When we set it up with our conversion factor and do the math, we get 0.01893, and then it starts repeating the 93. So we'll say 9394 just for our purposes. So that's how much of a mile he ran, about almost 2/100ths of the mile. So we've got our miles now, but we need our hours. So go ahead and try to convert your 3.1 seconds into hours. So unless you have really good memory of certain facts or quick computational skills, you may need to do multiple conversions sometimes. So when we have our 3.1 seconds here, we know that we want to take that seconds and turn it into hours in the end. But the problem is I don't know right off the top of my head how many seconds are in an hour. Now, of course, we could compute that, but I just wanted to show you this method. Sometimes it's easiest to say, okay, I know that there's 60 seconds in 1 minute. Now, that doesn't get me to the answer that I want, but then I can convert again and take minutes and turn it into hours. So we have 60 minutes in 1 hour, and now that will give me my answer in hours. Give me just a second. All right, now because 3 seconds is such a small portion of an hour, we end up with this kind of messy number of 0.000861 for our amount of hours. Now that's okay, because when we set that up and do the division of miles divided by hours, we actually find out that his speed overall was 21.99. So that gives us a speed of right about 22 miles per hour, especially since we probably had a little bit of error in our math. So the last problem on here, go ahead and try this. What was the cost per day? All right, now if each razor lasts for 1 week, that then means that 10 razors, each lasting 7 days, that means we're really looking at 70 days here. And if we want to know cost per day, that tells me we need to set up cost divided by days. So go ahead and try that. This then leaves us finding that his cost per day shaving is about 9 cents when we take the cost divided by days, and there we have it. That wraps it up for 1.5, so please make sure that you get the homework downloaded off of Schoology, try that, and let me know if you have any issues. Thank you very much.